Right. Right after the vertebral column, we would like to explain you about the rib cage, right? So this is going to be the right in front of the vertebral column, right? So as you can see here, let me grab my pen. So as you can see here, so of course in this region you are unable to find the vertebral column, because why? It's coming all the way through these, and you can see here this is the vertebral column, right? So at the back of this rib cage, you can see here T1, T11, T12, everything you can see here, right? So it's a continuity, right? So right after this region, so that's what you have seen in that image. So rib cage is coming over here in these regions, right? So in order to provide you the protections of your chest area, right? So the thoracic area, right? So inside this cage you are having your vital organs such as heart, lungs, and this is the opening, the abdominal opening, so where you are going to have your intestines, right? So let's go through this. So structures, of course, you can see ribs, sternums, thoracic vertebra, right? So what's the function? Protects thoracic organs. So that's the main function of these bones, right? So you can see here. So this is what you call the sternum, right? So this is a knife-shaped structure where all the rib cages are as a prolonged structures, you can see here, right? So from the thorax, from the sternum, most of the bones are getting developed over there in order to make the entire structure, entire rib cage structure, okay, right? So these are curved bony like structures, of course, you can see here, right? So from the sternum, so in theory we believe, right, we study that in this sternum region some RBC cells are being created from our internal organs, right, for our internal organs, right? So as you can see here, anterior view of the skeletal of the thoracic along with the sternum, and sternum is also being studied over here, right? So sternum is separated so that you can see how the sternum looks like, right? After that, we are going to study this pelvic region, because why? Thoracic region here, and of course here we are having the abdominal cavity where we do not have any bony like structures right in front of the backbone at the lumbar region, so that we are going back to the these regions, right? So we are having this pelvic cavity, right? Okay. So what do you have in that region is ilium, ischium, and pubis. And what's the main function? Support weight of the upper body, and also as a secondary advantage of this region is providing enough space for your vital or your reproductive organs along with its protections, right? So during the birth of the newborn baby, so this is the region where it has to get developed, and it has to make some openings in order to allow the baby to come out from your belly to the world, right? So you can see here there are so many whitish part like structures. We will be studying about what are such parts in our following slides. So just look into the structure, how it looks like, right? This is the region where our vital, our reproductive organs. For males we have for male we have testicles and penis. For females we have vaginal cavity along with womb and fallopian tubes. Everything is being placed inside these regions, right? So we will be studying those in the relevant areas as well in the anatomical structures, right? So don't confuse what are these kind of white areas. We will be studying those areas in the cartilages, right? So these femur, both femur are the thigh bones, right? And this is the end of the backbone, so base of sacrum, And you can see here the coccyx, right? As I have mentioned earlier, the coccyx is the remaining of our tail from our ancestors, as long that's what we believe from the science. Right now, coming back to the upper region again, and we would like to study about the upper limbs especially. So we are going to study about our both arms, right? So both arms are considered as upper limbs, and both legs are considered as lower limbs, right? So in this upper limb region, what we are going to study is clavicle, scapula, humerus, radius, ulna, carpals, metacarpals, and frenulets, right? So as you know that these types of anatomical structures are being named, um, and right after the inventions of these regions, and right after the inventions of each and every bones during the throughout the history of our science, right? So sometimes our pronunciation, right? So each and every country, or even though the name is similar, the pronunciation gets varied sometimes in a very vast manner. But look into the spellings carefully so that you can exactly understand what are we talking about, right? The pronunciations may vary from the regions where you are living, right? So US people spell this in a different way, Asians spell it in a different way, Europe they spell it in a different way. So that's not a point. Actually, here I would like to share you the knowledge, right? So get an idea about how the upper limb is placed and what are the regions we need to focus and we need to understand once we start talking about the upper limb region, right? So both arms actually. Right. So and again, once you go down, go below, you will be seeing the lower limb regions where we are having femur, patella, tibia, fibula, tarsals, metatarsals, um, phalanges, everything, right? So the lower limb means your leg regions, right? So from hip to your toe, right? So all you can see here in this structure, you will be able to find out the lower limb, so both legs. So as I believe that you can remember the longest bone in our skeletal structure is femur, right? So this is what you can see here. The longest bone, I mean the single piece, as a single piece you can consider here. But also this one is also looks similar, but it is not a single piece. Right, so these are the important things. Because why? Because I would like to share you the skeletal structure as per the perspective of biomechanics, right? So I'm not taking this as a anatomy class. That's why I'm not covering not too much things in this slide, right? So we will be studying these things continuously in our following slides. So this is since this presentation is a continuity of the biomechanics special course, the slides whatever we have shared is more than enough for you to understand, and in order to get the knowledge about the skeletal system and what are the components and what are the classifications we have inside it, right? So our main concern is getting the knowledge about the skeletal system from the perspective of a biomechanical engineer, or from the knowledge of biomechanics, right? Right. So so I believe that's enough for the for the skeletal system, and now let's jump into the muscular system. So in our early slides I have clearly mentioned you, um, bones are providing the surface for the muscles to be developed, right? So muscles are getting developed, or they are prolonged from the bones in order to develop over the surface of the bones, right? So where the force generations are taken places, right? So let's get into that concept. So basic functions, why we have a muscular system on the surface of the bones? Because why? In order to provide you the locomotions, right? So movements, stability, posture, heat productions, right? So there are so many other functions as well. This is very important functions what I have summarized here, right? So movement, stability, posture, heat production, right? And also your shape is also defined by the muscular systems, right? So what are the main types we are going to look into this talk is skeletal, cardial and smooth muscle systems, right? So basically we divide the muscle systems into mainly three parts where we are going to dig deep, and we will be studying about these things in order to understand from the perspective of biomechanics, right? So now let's focus on what do you mean by skeletal muscles, right? So as because why we have three main categorizations here: skeletal muscles, cardiac muscles and smooth muscles under the concept of muscular system. Let's focus on skeletal muscle as our initial one, right? So as you can see here, the structure of the skeletal muscle. So this is the bone region, so this is the skeleton, maybe whatever the area it is not a problem. So this is how it is getting the prolonged, it is getting in a prolonged way. It is how this is, it gets developed from the bone, right? So we do not have, even though we have gaps, the skeletal muscles are developed from the bones, right? So at a point it should have the it should have the connection over the surface of the bones, right? So structure straighted multinucleated, right? So multinucleated, of course, in the cell structure. So as a living organisms we have human cells, right? So we are made out of trillions of cells. So inside each cells we have a nucleus, right? So as I just want to summarize you about the atoms as along with the cells, right? So atoms are the basic fundamental structure of non-living things, right? So similarly in living things we have what do we have in living things is we call cell, right? So inside the atom as well as inside the cell we both have nucleus, right? Because nucleus are the main body which controls the entire cell or entire atom, right? Since we are focusing on the anatomical structures, let's stick together with the cells. So in each cells we will be having each in a single atom. Sorry, in each cell we have single what do you call nucleus, right? But in this skeletal muscles, there will be structures where you can observe multiple nucleuses, right? So that's why we call multinucleated. And straighted muscles, of course, you can see here physically it looks like very straight. We do not have a curved or twisted structures, right? So what's the function of these skeletal muscles? What are the advantages we can get it from this is voluntary movements. What do you mean by voluntary movements? Is the movements whatever you wish to make is considered as voluntary movements. For example, if you like to walk, you have to think that you need to locomote, right? So you have to locomote, right? So you have to come from one place to another place. That's your wish, right? So you could have wished that you stay still at the same place where you have started, right? But you thought that you need to move, that's why you moved. But in order to provide you this movement, you are wishing that you need to make a move, and you are ordering or you are commanding your voluntary muscles in order to make forces where you are getting the benefits of making a movement, right? So this is under your control, because why? Your brain, you wish, and your brain provides the signals for these types of muscles. If you do not wish, then there are no signals or no commands for these muscles. You can stay still. So all the actions whatever you are doing using these voluntary muscles are being controlled by yourself. So look at the structure. It's an easy structure. You can study this structure for your anatomical purposes or for our future studies. Right. Secondly, we would like to see cardiac muscle tissues, because since the name precisely says cardiac muscle tissues, this is a totally different structure from the skeletal muscles. So cardiac muscle structure, we can only observe these type of muscle structure in the heart. We are unable to observe these type of muscles in the other regions, right? So voluntary muscles or the skeletal muscles we can see all over the body wherever you are using in order to make your voluntary moves, right? So as per your wish. But heart, you are you controlling your heart? No, right? So it carries out its duty as a pump without your wish, right? So it is not under your control. So the structure and the physical appearance and the chemistry, whatever it's going on inside, is totally irrelevant to your wish, right? It is not under your control. So that as per its functionality, its cells are developed, its structures are developed, right, from the perspective of its muscles, right? So structure straighted, similar to the heart muscles, single nucleus. So in these type of muscle cells we will be observe only one nucleus, right? So in skeletal muscles we will be observe multi-nucleuses, right? Intercalated discs, right? So we will be seeing these types of structures where we can see intercalated discs. So it is kind of a structures, right? And what's the function? Involuntary contraction of the heart, of course it is only in the heart, right? So you can see here, this is how it looks like. Right, the third type of muscle, and third and the last type of muscles we will be having here is smooth muscle tissues. So these types of muscles will be placed in the other organs apart from the heart tissue and the skeletal tissues, right? So structure, non-striated, single nucleus. Again it is single nucleus, you can see here. So this is the muscle cell, especially the smooth muscle cell. You can see here a single nucleus, similar to the heart tissue, right? But it is not a straight structure, it is kind of an oval shape, right? So elongated oval shape, precisely said, right? So what's the function? Involuntary control of internal organs. So you have several internal organs which are not under your control. For example, let's take your intestine, right? So once you put your food into your mouth, you just chewing is under your control, and when you swallow again is also under your control. Right after your swallow, you can't control anything else at all, right? So everything is being controlled by these involuntary muscles, which are directly getting orders from the brain. Again, brain, you have some certain parts of the brain where you can control, the other part you do not have, right? So that's the region where these types of involuntary muscles are getting orders from, right? So your intestine, lungs, kidney, everything, right? Even whenever you blink your eyes, another example is blinking eyes, right? So you are not giving order to your brain in order to make your eyes blink oftenly, right? So no, it isn't. Once you start thinking about it, then you can take a control over it. But without thinking, it is happening, the blinking process is happening in order to protect your eyes and in order to make the lubrications over the surface of the eye, right? So these types of movements are controlled by the brain's regions of involuntary movement control section, right? So these are the regions of our body, especially as I said, right? So organs which are controlled by the brain for the involuntary movement purposes, and the total and the structure of these involuntary muscles are totally different from skeletal muscle and heart muscles, right? So this is the third part, third appearance, or the third variety of the muscle tissues, right? Now let's think about how the muscles are contracting and making the energy, or making the force, in the other words, right? So sliding filament theory, we call sliding filament theory actin and myosin interactions, right? So inside it we have a couple of proteins we call actin and myosin. So these are getting together and making an interaction, where we developed a theory, sliding filament theory, where the muscle cells are contracted and generating forces to us to make the movements, right? So I have a nice YouTube video in this slide attached. I would like to share it with you so that you can have a quick overview about this theory, because since it's a theory, you have to understand the image, the process, right after the first process, right? So there, I think there will be 4 stages. So if I start showing some images, you won't get a clear idea. It's better to watch a video so that you can understand the entire process in a very precise manner using this clip, right? So let's watch it together. Oops, it likes. Okay, then let me paste this. You are offline. What? Oh, sometimes we may have these kind of issues during the days of whenever we have a heavy rain here. It is very problematic to us to continue the online activities or the recording sessions due to the poor connections, right? So it's our fate to have such poor networks. But anyways, we have to go through this. Other than that, we do not have any options. So let me do. Let me switch back to another network and give a try again. Again. Oops. Okay then, let's not waste our time by spending our time. Okay, no. It's not going to work, guys. Right? Okay. Let me close this and come back to our normal things. Okay. Okay. Okay, so I already had a nice video clip where we can see these things in a very nice way. Let me do these things, right? So rather than waiting for the network to get connected, and we are wasting a lot of time over there by waiting for it, right? So let's do like this. I'll be sharing these links in the comment section so that you can have a view, because I really recommend to watch these clips so that you can clearly understand how this theory works, especially the sliding filament theory and the actin myosin interactions, in order to make this theory true, so that how we are generating the forces and all, right? Please have a look at this link, whichever I attached in the descriptions, right, since it's a recorded session. So let's go to the other one. Right. Okay, major muscle groups, right? So again, as you know, we have once we study the entire system, generally as an overview. Then we divide it into a couple of categorizations as per the functions or as per the location, right? So considering by several other key factors, right? So now let's categorize the muscles system as the major muscle groups in the upper body region. So what are the regions which are going to be covered here is shoulders, right? So deltoid, rotator, cuff muscles, so all of these regions you can see here, right? And arm, bicep brachii, triceps brachii, right? Forearm, flexors, extensors, of course you can see here in these regions, right? So if you are too much interested about developing or if you are a gym person, then of course you have you may have heard about these muscle regions oftenly, I believe, right? And again, the second category we can divide it major muscle groups in at the lower body regions, where you can see here your thigh and your back regions, right? So hip, gluteus maximus, so this is the region gluteus maximus, so right, so at the buttocks part. And the other one is iliopsoas and thigh regions. You have quadriceps and hamstrings, and at your leg you have calf muscles, of course, right? So gastrocnemius, solaces, right? So because these are too much anatomical structures, since we are not focusing, we are not studying about these things from the perspective of anatomy, I'm not going to teach you too much. I'm not going to dive deeper into these muscle regions, right? So our main concern throughout this presentation, right? We are having several presentations. You can check it in our channel if you really like to get more knowledge about this. We are sharing this as per the perspective of biomechanics. We would like to just give you the introductions about these parts. These are the things existing, and these are the categorizations. These are the things you need to make awareness about these things, right? Right. Now coming back to the engineering part of this region is muscle attachments and liver systems, right? So in physics we have studied in our small grades, we have liver in order to make our work easily done, right? So what's the purpose of the liver in physics? At physics we studied is we are using livers in order to ease our effort to make a work done, right? So similarly we have three liver types. So similarly we can make some examples at some places of our body where we can equalize these three livers inside our human body, right? So how we are applying this liver knowledge inside our human body, again in order to understand its structure, how it is naturally placed all these physics inside us in order to make the things happen without too much effort or without voluntary concerns, right? So you can see here the three liver classes here. So the first class is we are having a load at a side, and the other side we are having effort, and fulcrum is the point where we are having the center part. It's kind of a scroll. We can imagine it's kind of a place where we are having the movements, right? So once we have load over here, effort over here, we will be having movements here along with the here by having the fulcrum at the middle part, right? So similarly you can see here at the neck region you can make the movements such as efforts, loads, and we consider the backbone as the fulcrum, right? So you can easily combine these two images, right? So first class, here also we have the first class liver which are being applied in these regions. So effort, fulcrum, load, effort, fulcrum, load. At the side we have load, here we have load, at the opposite side we have effort, and similarly we have here, and at the middle part we have fulcrum, right? Okay, now let's go to the second class. You can see here effort. Right after effort comes load comes right after the effort. So initially we have effort, and then we have a load, and right after that we have a fulcrum. See, look at this one. Effort is at first, and load is at second, and fulcrum is the third one, right? So as the first one, in physical world we use pair of scissors as one of the applications, right? So in physiology we use these types of actions in these regions, but in the physical classes we have several other structures like this.